Hello everyone, welcome back. Let's continue with the second part of the video. Those who haven't watched the first part, I would highly recommend doing so in order to fully understand the topic. The link of the first part you can find in the description below.
So here you can see a couple of iterations have already been finished. So we can see what we got. So report. So here we have normally you can see only one window that is of residual, but here we have uh, some extra window, and those windows are coming because of the report plot. I have made some changes, so I will tell you what I did during that break. So let's go over here. So here you can see this one is the cell 1 underscore temperature. So you can see how the temperature is changing with the time. So you could already calculate roughly with hand calculation. So how your temperature should change. So once you know how it should behave, and so you during the simulation you can plot and see if it is behaving in the same way as you expected. So at really initial stage you can figure out the problem. So for example, if the temperature would have been going really high, so I could know that there is some problem. So sometime it happens this solution get converged, but maybe you have given a really high the heat source, you have put some extra zero, so in that case the temperature would go really high. So that's not what you were expecting something. So it means in that case you have made that mistake that you cannot figure out with the residual, but you can only figure out when you were recording this temperature. So anyway, here we know how the temperature is changing and we should know how it should behave. So we were also recording the flow rate. So in flow rate, so there is one interesting thing. So here you can see three lines. So we have inlet flow. So inlet flow, I had provided 30 gram per second total flow, and the outlet flow was also 30 gram per second. So and the net flow should be zero, but I think you have already figured it out because the fluent by convention, so inlet flow is taken as positive and outlet flow is taken as negative. So we had written an expression that inlet minus outlet, so it means inlet minus outlet, so it will become positive, so it is adding these two. So either you have to write absolute or you would have added inlet plus outlet, then you would have got zero. So but anyway, so here it is also a good indication. So addition of these two is exactly the same, so it means you are getting good conversion for the continuity equation. So I have plotted this in net flow rate separately. So that's how you can see how your simulation is going on, and you can see your progress of the simulation with the help of these plots. So now let's see what we can do with the file. So I'm stopping this simulation over here. So you can stop at the end of time step, or you can stop at the end of iteration. So I'm stopping at the end of time step. So meanwhile here you can see another thing. So this one is some extra information. Time step 38 flow time, outlet temperature, outlet flow. So all these. So you remember when we were defining the report file. So we said that we want to print all those results on the console. So it is printing all those results on the console where we can find those results. So for that you need to go into the data structure. So here I am running this one scenario 2. So you will go into the scenario 2 file, and here you will see design point 1 to 1, design point 1, design point 2. So where should I go? So for that you will go to the workbench, and as I am doing parametric studies, so when I will open this parameter, so here you will see these parameters are open. So currently I am running design point 2. So because this one is the current, so this one is running. So I'm design point 2, so it means simulation has finished. So it means I'm currently running DP design point 2. So it means I have to go design point 2. So here again you can see triple F minus 1. So this one is the for Fluent. So actually I am running this second one. So this one is the Fluid Flow Fluent FFF, and then Flow Fluent 1. So that is the general name. So here Fluid Flow Fluent and Fluid Flow Fluent 1. So I have to go in this one because that's what I'm doing. And here design modeler Fluent mechanical post processing. So we are running Fluent. We will go into the Fluent, and here you can see all those files. So these are some just my lame name. I was doing some practice with the uh, UDF. So anyway, here we had saved simulation data. So you can see it is a text file. So you can open with the text file, with any text file, and that's how you will get those results. So your results will be written something like that. So here you have all those variable, and here you have all those your data. So for post processing you can do a lot of different things, but this text file, I think you are already familiar. It is really easy to do all this post processing with the Excel. So how you can do that, so let me show you quickly, and let me open Excel. So how you can read your text file with the Excel, for that I have a video on my channel about on the Excel to open the text file. So different ways of opening text file into the Excel. So you can check this video. I will provide the link in the description. So for that, just you can, for example, copy, and you can paste over here. And then if you go to the data, then you will go to the text column, and I'm not going to into the detail. You can check later. So anyway, so that's how your results have been separated. So that's how you can separate your data. So here this one is the first column is your time step. So 0 time step, 2 time step. So I have separated based on space. So that's why time step has come into the different columns. So just let me delete this one and shift left. So here is your time step. Here is your time step. Here is your flow time. So time step, because we were saving at every second time step 0 2 4 6, and here is your flow time. So I have used UDF, and so flow time is changing. It is not constant, so it is changing based on the UDF. And then here are all those parameters which you have saved. But anyway, so that's how you can open your text file with the Excel and do your post processing. So here, so what you can do, for example, I had stopped this simulation during my run. So if I want to continue from here and I want to write my data further, so if you click on the calculate, so your simulation will start from your last time step, and it will continue writing data into your same file. So it will not overwrite, so it will append your data from at your previous data. Okay, so I have stopped simulation. So this 41, before we had 40, so this 41 should have been there now. So let's open this one with the text file with the notepad. Yes, sorry, 42, because we were saving at every second time step. So 42 has been added. So it means it doesn't matter if you interrupt your simulation, so you can write your data into your previous file. So yeah, so yes, that's it for today. I hope you found this tutorial helpful. So if you have any question or any suggestion, leave them in the comment below. Thank you, and see you in the next video.